Hey guys, today we're going to be looking at 7.3, which is going to talk about the law of cosines. Last time we talked about the law of sines, and now we're moving on to the law of cosines. The law of cosines is in this table right here. We've got three different versions of it. It's the same thing. I just wrote it out three different times based off of what angle you have or what sides you have and what side you're trying to find. So we've got a squared is equal to b squared plus c squared minus 2bc cosine of angle A. B squared is equal to a squared plus c squared minus 2ac cosine of angle B. And c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. So remember, we're using this with our oblique triangles, just like we did with the law of sines, to help us solve for those missing parts. So example 1 right here says a surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of a lake. While standing at point C, she finds that B, side B, because it's a lowercase b, is 259 meters, side A is 423 meters, and angle ACB, so angle C, measures 132 degrees and 40 minutes. Find the distance of side C. So if I'm trying to find the distance of side C, I probably want to use this version right here, where we've got that C squared over there. This also comes from the fact that I know angle C and side A and side B. So that's the version that I'm going to use here. I'm going to go ahead and write it down here. C squared is equal to A squared plus B squared minus 2AB cosine of C. And I'm going to start plugging in the different things that I know. So I'm trying to find C, so I'm going to leave that as C squared. I do know that A is 423. So it's going to equal 423 squared plus, I know B is 259, so 259 squared. Let me scoot that over a little bit. Minus 2, I'm going to times 423 times the 259. And then it's times that cosine of my angle C, which is the 132 degrees and 40 minutes. Okay, to get C by itself, I need to take the square root of both sides. Now, normally when we take a square root, we use a plus or minus, but we are trying to find a distance across the lake. So that's going to be a positive value. So I'm just going to take the positive square root. So the square root of 423 squared plus 259 squared minus 2 times that 423 and that 259 again times the cosine of 132 degrees and 40 minutes. And I'm going to go ahead and plug it all into my calculator. So if I'm looking, I need to make sure that my calculator is in degree mode, since we're looking at degrees here, which I am in radian mode, so I need to fix that. And then I'm just going to plug it all into the calculator. The square root of 423 squared plus 259 squared minus, oh, I forgot a squared. Be careful with how you plug stuff in. There we go. Minus 2 times 423 times 259 times the cosine of 132, second apps 1 to get the degree sign, and 40, second apps 2 to get that minute sign. And there's our answer. Let's go ahead and round it to 4 decimal places. So 628.1008 meters is the distance across the lake there. Now that was just finding one missing part, that one side of the triangle. Sometimes we'll need to find all of the missing parts of the triangle, solve for everything. So that's what we're going to look at in example 2 here. It says solve the triangle if angle A is 42.3 degrees, side B is 12.9 meters, and side C is 15.4 meters. So something I do that kind of helps me just check and make sure that I get everything is I write it all out over here on the side. So I'm going to say angle A equals something, side A, angle B, side B, angle C, and side C. And then I'm going to check off what I already know. Angle A is 42.3 degrees, side B is 12.9 meters, and side C is 15.4 meters. So what I'm going to do is I'm going to start by finding that one missing side, side A, and I'm going to use my law of cosines up here to help me do it. Side A means I probably want to use that first version of it. So I'm going to come over here, zoom in on where I can see my triangle, and find my missing side, A. So remember that's A squared is equal to B squared plus C squared minus 2BC cosine of angle A. And let's just plug it all in. So I'm going to say A squared is equal to 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4, scoot it over a little bit, times the cosine of 42.3 degrees. To get A by itself, I'm going to square root both sides. So A is equal to that square root. Square root of 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. And I can plug it into my calculator. So the square root 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 cosine 42.3. Oh, gotta be really careful. I keep messing up plugging stuff in, so do better than I am. 42.3 cosine non-real answer. And so I messed up plugging it in. Square root 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times the cosine of 42.3. There we go. Okay, like I just said, be better than me. Be really, really careful when you're plugging stuff into the calculator. I'm trying to do it quick so you don't have to sit here and stare at my calculator while you're watching the video. 10.4738 meters. Now I will look over here and see that both of my other sides are just one decimal place to the 10th. So I'm going to round my answer just like that. So I'm going to say 10.5 meters. Now I'm going to section this off and move on to the next part. What I do from here is I look at my angles that I'm missing, angle B and angle C, and I find the one that has the smallest side length and start with that. So B is the smallest side length, so I'm going to start with angle B. And that also has to do with the caution box that I have right here. It says, had we used the law of sines to find angle C rather than angle B, you could get two different possibilities. You wouldn't know if it's going to be 87.1 or its supplement 98.3. This kind of goes back to our law of sines with our, we don't know if it's one or two possible triangles, the different cases. So always start with that smaller side, that smaller angle, so that you can figure out then what the other angle should be based off of that smaller one. So I'm going to do that in blue, and I'm going to use my law of sines to help me. So I know angle A, and I just found side A. I'm just going to put A for right now, and it's going to be over the sine of that 42.3 degrees. And from here, like I said, we're going to try and find angle B. So I'm going to do 12.9 over the sine of B. I need to cross multiply. So I'm going to have A times the sine of angle B is equal to 12.9 times the sine of 42.3 degrees. And the reason I'm just using A is because I don't want to have to type out this super long 10.473765958. I don't want to have to keep writing that decimal over and over again. From here, I do need to actually divide by that A to get the sine of B by itself. That gets me that fraction of 12.9 sine of 42.3 degrees over A. And then I need to get B by itself, so I need to do my inverse sine. The inverse sine of 12.9, sine of 42.3 degrees over A. And then this is where we're going to do kind of what we talked about last class period to make sure we're getting the most exact answer possible. I'm going to use my calculator to help me make sure I'm using the exact value for A. So I'm going to do inverse sine, and then I'm going to do 12.9 sine of 42.3. And then in the bottom, I'm going to do second and the negative sign. A and S stands for answer. It's going to take my most recent answer, which is my value that I got for A. And it's going to take that exact value instead of the rounded decimal answer. So then from there, I can hit enter, and it gives me my answer. My angle is going to be 55.9874 degrees. Angle A is only rounded to one decimal place. So let's match angle B with that. 55.98. That's actually going to round up to 56 degrees. And then finding angle C is actually the super easy part because now that I know two angles, I just subtract them from 180. So 180 degrees minus the 56 degrees and minus the 42.3 degrees. So that's my last step there. 180 minus 42.3 minus 56 gets me 81.7. So angle C would be 81.7 degrees. And we've now found all of the missing parts that we needed. We needed to find side A, angle B, and angle C. So let's do it again. We're going to do example 3, solve the triangle. This time we don't have a triangle drawn for us, so let's kind of sketch one in. I'm going to do it, let's do it over here. I've got, let's say, angle A, B, C. So it tells me A side is 9.47 feet. Side B is 15.9 feet. And side C is 21.1 feet. Let's do B in blue, and we'll do C in purple. So what I need to do here is I actually need to find all the angles. That's what I'm missing. So I need to figure out what angle A is. I know side A. Angle B, I know side B. And angle C, I know side C. It goes up a little bit. So side A is the 9.47. Side B is the 15.9. And side C is the 21.1. So let's use our law of cosines to help us find one of those angles, which means we are going to have to do a little bit more work here to work backwards and find one of those angles. So let's start with angle A because it's across from the smallest side over here. So I'm going to do A squared is equal to B squared plus C squared minus 2BC cosine of A. I'm going to plug in what I know. So A squared would be 9.47 squared equals 15.9 squared for B plus 21.1 squared for C minus 2 times 15.9 times 21.1, any decimals there, times the cosine of A. Okay, I'm going to be lazy when I start to solve this, and when I'm plugging stuff into the calculator, I'm going to go ahead and move this over, the 15.9 squared and the 21.1 squared, and then plug that all in the calculator at one time. Let me get my calculator back up. Let's screen. So I'm going to do 9.47 squared minus 15.9 squared minus 21.1 squared. Okay, that gives me a negative 608.3391. And I'm also going to do the negative 2 times 15.9 times 21.1 to get me a negative 670.98 cosine of A. I'm going to divide both sides by that negative 670.98. So the negative 608.3391 divided by, and I can hit second answer to save myself some typing in. Ooh, that gets me not a pretty decimal, so I'm just gonna leave that fraction when I write it. And then to get A by itself, I need to take that inverse cosine. So I'm gonna say A is equal to the inverse cosine of that fraction. But when I plug it into my calculator, I can just do the inverse cosine of second, the negative sign to get that answer. And I get that A is 24.9546 degrees. I don't think that we need to round it quite that much. Let's do 2 decimal places. So I'm going to say that A is 24.95 degrees. So I found one of my angles. From here, I could use the law of cosines again, or I could use the law of sines to find my next angle. My next smallest side is B, so the next angle I'm going to go for is B. I'm going to use the law of sines just to give us some extra practice with that. And that means I'm going to set up my ratio of side A over the sine of angle A equals side B over the sine of angle B. So let me section this off and zoom in. Step 2, I'm going to do A over the sine of A, which side A, actually I know that, is 9.47. And that's going to equal side B is the 15.9 over the sine of B. I'm going to cross multiply. So 9.47 sine of B is equal to 15.9 sine of A. Divide by the 9.47. So the sine of B is equal to that fraction. And then take my inverse sine. Okay, when I do my inverse sine, I want to make sure I use that exact value for A. So I'm going to do inverse sine. I'm going to do alpha x for my fraction, 15.9 sine of second negative sine to get that angle for A. And then on the bottom, I'm going to do the 9.47, which means for B, the angle I get is 45.1019. So when I round it over here, that would be 45.10 degrees. And then remember, the last one, always the easiest. I just do 180 minus 24.95 minus 45.10. 5.10, and I get 109.95. So I found my angle A, my angle B, and my angle C. So the ones where you have to solve for like all of the missing parts, That's kind of annoying because that's a lot more work, where you just have to solve for like one side, like we did in example one. That's not too bad. So let's look at example four. This one just says find angle of B to the nearest degree. So just solving for one part. I know all of my side lengths, but I need angle B, which means I need to use the law of cosines part that has angle B in it. So I'm going to look at B squared equals, get A squared plus C squared minus 2AC cosine of angle B. So like I said, we know across from angle A would be side A, across from angle B would be side B, and across from angle C is side C. So let's plug it all in. I'm going to say B squared equals, well, A is 11, so 11 squared, plus B is 9, so 9 squared, minus 2 times that 11 times the 9, and then cosine of B. We got to do a little bit of work here to go backwards and find that B. So 6 squared is 36. I can go ahead and just like subtract everything over though, because I am just going to use my calculator for some of this. So let's subtract 11 squared, subtract 9 squared. So remember 11 squared is 121, 9 squared is 81. So 6 squared, 6 squared minus 11 squared minus 9 squared means we're looking at negative 166 equals, then I've got negative 2 times 11 times 9, so negative 198 times the cosine of B. I'm going to divide by that negative 198. I'm just going to leave it as a fraction for now. So negative 166 over negative 198 equals the cosine of B. Because I'm going to have to do my inverse cosine, and I'll just plug it all into the calculator then. The negatives do cancel out, so I get 166 over 198. So the inverse cosine of 166 over 198, that's not an 8, that's an 8. Nope, up. There we go. Is going to give me 33.0302 degrees. And then the last thing in this set of notes is our area formula that matches with the law of cosines. So we had an area formula that went with the law of sines. This is the area formula that goes kind of with the law of cosines. It's called Heron's area formula. It goes with the side-side-side version of the triangle, which is what we just looked at in example 4. The side-side-side version of the triangle is the one that you would probably most likely use the law of cosines on. That's the easiest thing to use. The law of sines gets kind of tricky when you are looking at a side-side-side version of a triangle. So it says if a triangle has side lengths A, B, and C, you can find the semi-perimeter by, well, semi means half, so taking the perimeter and multiplying it by 1/2. So 1/2 times A plus B plus C. So then the area of the triangle is the square root of, well, the semi-perimeter would be S, so S times S minus A times S minus B times S minus C. So let's look at an example here. It says the distance as the crow flies from LA to New York is 2,451 miles. From New York to Montreal is 331 miles. And from Montreal to LA is 2,427 miles. What is the area of the triangular region having these three cities as vertices? Ignore the curvature of the Earth. So let's start by finding the semi-perimeter. So I'm going to do 1/2 times 2,427 plus 331 plus 2,451. I can plug that into my calculator. So 2,427 plus 331 it would help if the number is actually typed, plus 2451, and that gets me 2604.5. And then I'm going to plug them into that area formula. So it's going to be the square root of that 2604.5 times that 2604.5 minus 2427. I'm going to need to move this down here where I've got more room. Times that 2604.5 minus the 331, and the 2604.5 minus the 2451. And then I'm just going to plug that into my calculator. So square root, and I'm just going to do second answer. The second answer minus 2427. Second answer minus 331. Second answer minus 2451. I'm going to be lazy here. Okay, that gets me kind of a big number here. 401,664.1109. And this is an area, so miles squared. And there you go. Great, that's it for this set of notes. Let me know if you have any questions. Get started on your assignment that goes with this, and y'all have a good day.